Hi guys, Audrey here, and this is a JAC capsule on exponent rules. In this video, we're going to do a few problems to help us put together all those rules and see how they can be used to simplify things. Let's go. So before we get started in this video, I urge you to go to the John Abbott website and download the document called Exponent Rules and Simplification Theory. In that document, you can find a page that have all of these problems. So sit down, give them a try yourself after having learned all of the exponent rules, and then come back and watch the video if you struggle, or just to make sure that you got everything right, or even just to hear some explanations that you might have missed. All right, let's go. So in this first question, we have 3x cubed y squared all squared. So we have a rule that tells us that this 2 right here can be distributed inside to each of these things. So in other words, this is the same thing as 3 squared, x cubed squared, y squared squared. Exponents can be distributed inside of multiplication, but beware, they cannot be distributed inside of addition or subtraction, only multiplication and division. All right, so we have 3 squared, I'm just going to rewrite that a little bit bigger. So we have 3 squared, x cubed squared, y squared squared. And then that equals to 9x cubed squared. We have another exponent rule that tells us that when we have a power to a power like this, we multiply them together. If you don't know that rule, make sure you go watch the video about it. So here this becomes 9x to the 6th, and then 2 times 2 is 4, so that's y to the 4th. So these values are just multiplied together. And this is my final answer. All right. Number 2, we have x squared times x to the 7th times y cubed times y to the negative 1. So we have another exponent rule that tells us that when we have the same base and different powers, we add those powers together. Again, if you're a little bit confused, make sure you go watch the video about this exponent rule. So then this becomes x to the power of 2 plus 7, y to the power of 3 minus 1. So this is x to the 9, y squared. Note that I also could have thought about this in a different way. Some people like to get rid of negative exponents before doing anything. So I could have also thought of this as x squared, x to the 7th, y cubed, all over y. Remember, negative exponent just means bring down to the denominator. So then this still becomes the same thing. X squared, x to the 2 plus 7 is 9. And x to the 3 minus 1 is 2. We could also think of this as just canceling out one of those y's, which means that there are 2 y's left over in the top. So there are a few different ways that you could think about this. All of them will get you to the value x to the 9th, or to the answer x to the 9th times y squared. All right, let's look at number 3. X to the 4th over x to the negative 13. I'm just going to make that a little bit bigger so we can make sure that we can see it. X to the negative 4 over x to the negative 13. In my opinion, the simplest way to go about this is just x to the negative 4 minus negative 13. So that's negative 4 plus 13, which is x to the 9th, and that is my final answer. However, as before, some of you might want to get rid of negative exponents first. And negative exponents just mean flip the fraction. In this case, both x's are to a negative power. So I could also say that it's equal to x to the 13 over x to the 4. And again, this is x to the 13 minus 4, which is just x to the 9. We still get to that same answer. Okay, number 4. We're doing the square root of 50x to the 4th. The square root of 50x to the 4th. Well, there are a couple ways that I could think about this. Square roots are like powers. They're like exponents, and we know that we can distribute exponents inside of multiplication. So in other words, this is the same thing as the square root of 50 times the square root of x to the 4th. So then we remember that a square root is just the same thing as the power of a half. So I'm going to leave this square root of 50 as is, but I'm going to write this x to the fourth as x to the fourth to the power of a half. And then we're just multiplying our exponents together. So this is the square root of 50 times 4 times a half is 2x squared. Now, when we think about that, it really makes sense that the square root of x to the fourth is x squared. Because what do I have to multiply by itself 2 times to get x to the fourth? The answer is x squared. So this is x, the square root of x to the fourth is the same thing as the square root of x squared times x squared. We've got 2x squareds under there, so we take 1 out and get rid of that square root. Now, we're going to simplify this a little bit further by thinking about that 50 as well. So I'm just going to think about 50 in terms of its prime factors. 50 is equal to 5 times 10, but 10 is equal to 5 times 2. So the square root of 50 is equal to the square root of 5 times 5 times 2. But as we mentioned, we can distribute that root. So this is the same thing because we're distributing it inside of multiplication. We can distribute roots inside multiplication. So we get the square root of 5 times 5 times the square root of 2. But the square root of 5 times 5, what do I have to multiply by itself? What do I have to multiply by itself 2 times to get 5 times 5, or 25? The answer is 5. So 50 is just equal to 5 square root of 2. So my final answer up here would be 5 square root of 2 x squared. All right, now we've got 2 problems left, and both of these problems are really common problems in calculus. This is the type of thing that you're going to be simplifying a lot. So let's pay careful attention to them. Now, in number 5, we have 6x squared plus 4x to the fourth minus the square root of x over x squared. Now, it's important to remember that there are these implied parentheses around the numerator. If you don't know what that means, if you're confused about that, make sure that you watch the order of operations and implied parentheses video. This idea of implied parentheses is quite useful. Okay, so one of the things that we know is that because of those implied parentheses, the first thing we would do to evaluate this would actually be to do that subtraction. But we don't have an x value, we want simplification. So we can actually start by distributing this inside of that subtraction. So in other words, this becomes 6x squared plus 4x to the fourth over x squared plus, and I'm going to rewrite that square root of x as x to the 1/2 over x squared. So here I applied my exponent rule to change that root into a power, and I also distributed the denominator. We know that we can distribute denominators to different terms in the numerator, but we cannot distribute the numerator to different terms in the denominator. All right, so now we just have the exponent rule that we've been using in the previous problems. We have x to the fourth over x squared. We know that we do x to the m over x to the n is equal to x to the m minus n. So this becomes 6x squared plus 4x to the 4 minus 2 plus x to the 1/2 minus 2, which gives me 6x squared plus 4x squared plus x to the negative 3 over 2. Now check this out. I actually have some like terms here. Those are both x squared terms, so we can combine them to get 10x squared plus x to the negative 3 over 2. And that is my final answer, and that is the way that you're going to want to think about this for a calculus class. However, it is sometimes useful to get rid of negative exponents, so we could also rewrite this using our negative exponent rule as 10x squared plus 1 over x to the power of 3 over 2. All right. So it's not useful or necessary in the context of a calculus class, but it can also be sometimes helpful if you need to evaluate to think about what x to the 3 over 2 actually means. Remember, that is the same thing as saying the square root of x cubed. So if I needed to plug something in, understanding that would be useful. All right, let's go to question 6. we have 6 the square root of x times the square root of x minus 5x squared over 30 times the cubed root of x. I'm going to rewrite that so my x's all have powers. 6x to the 1/2 minus 5x squared over 30x to the 1/3. And again, we're in this situation where we have multiple terms in the numerator, but only one term in the denominator. So we're going to distribute that one term in the denominator to the different terms in the numerator to get 6x to the 1/2 over 30x to the 1/3 minus 5x squared over 30x to the 1/3. Now, a thing that's useful sometimes when you have fractions in both the numerator and the denominator, to make sure that you don't move things around incorrectly or accidentally apply rules when they're not allowed to be applied, you can take those constants and move them to the front. So I'm going to take that 6 over 30 and just stick it out front. Then what I'll have left is x to the 1/2 over x to the 1/3. Then minus, I'm going to take that 5 over 30 and move it out to the front. X squared over x to the 1/3. Now I'll apply my exponent rules, but at the same time, I'm going to simplify my fractions. 6 divided by 30 is 5, so 6 over 30 is 1/5, x to the 1/2 minus 1/3. Then 30 divided by 5 is 6, so this is 1/6, x to the 2 minus 1/3, giving me 1/5, x to the 1/6, minus 1/6, x to the 5/3. And that is my final answer. And remember that x to the 1/6, that's the same thing as the 6th root of x, and that x to the 5/3 is the cubed root of x to the 5th. Now, if there were any rules that I used here that were a little bit troubling to you or that you struggled with, make sure to go back and watch the video on that rule, the specific video on that rule, and go do the exponents practice problem sheet to make sure that you've got these things down and that you're capable of simplifying everything. All right, that's all. Bye, guys.